Welcome to lesson 3. This lesson is continuing the series of lessons that looks at the plate boundaries or plate margins, as you call them, and we'll go on to look at the convergent boundaries. So let's just activate this. As I showed you in the last lesson, I'm not quite doing it here. We're focusing on making sure that you're aware of convergence, divergence, conservative. We're going into the processes which are talked about here, but also the landforms that come along with that. 2020 paper linked how important were physical processes in the formation of volcanic hazard landform types sort of question. So there's the relevance of it. This only concentrate on the convergent boundary and two forms of that where we get destructive sort of landforms being formed. So often these convergent is often synonymous with destructive plate margins, although there is the third, which I'll talk about separately. So the two sorts, ocean going beneath continental and a denser ocean going under another less dense ocean plate. And going back to some of your fundamentals here, remember the general rule is ocean plate is denser, although albeit thinner, than continental plate, and where the two meet and push together, the dense one goes beneath the continental plate. So the terminology that we'll be using here, I'll just summarize in the next slide. So we'll go through things like this word subduction, make sure you're clear on that. Reminder about things like convection cell, slab pull, less so on ridge push, and some of the key landforms that we need to do. One's missing actually from this list, but then this is about continental oceanic. We'll be looking at fold mountains, ocean trenches, types of volcanoes, and also in the latter part of the presentation, we'll look at island arcs. Most of my explanation will be using this very colourful diagram. Almost looks like some sort of, I don't know, rodent without legs. Very interesting, strange tail there. But the reality is this. What we have here is the classic one that's used, where ocean goes under continental. The South American one is used in many, many textbooks, where the Nazca ocean plate, you see the Pacific over there, is forced beneath the continental plate here, the South American plate. Okay, and then you can see some things I've talked about in the first lesson, the mantle, the asthenosphere, that's the mobile part of the mantle, where you've got flowing taking place. So I'll talk about the processes and the landforms linking to this, although later on you'll see some other slides which kind of recap over this, and you'll see from a slightly different sequence point of view as well. So if we go back to the beginning, we're saying here these two plates are moving towards each other. The convection cell, if I just use that to briefly indicate that, push the two plates together. This plate being denser collides with this and is forced beneath it, and I use that word subduction. Once this slab is on its way down, we've also got slab pulling it down as well. The continental plate cannot go underneath it, so what it does, it compresses, it folds upwards. That's why we get those fold mountains, but we get this warping taking place, so this bending, and it creates a trench-like feature. These are the deepest points in the ocean. This particular one, the Peru-Chile Trench, is I think around about 8.5 kilometers deep, and the deepest is the Marianas Trench in the Pacific Ocean, I think close to 11 kilometers deep. So we get this very big macro feature, this ocean trench, and it's got ocean sediment and sediment coming off the land as well. So that's a feature that you need to be able to explain. We get this folding. If you think about folding up a piece of cardboard or a piece of paper, it gives you the basic idea, and it's folding upwards, so theoretically getting higher all the time, but also counteracted by things like subaerial processes, erosion as well, so it kind of gets worn down as well. And the Andes are a great example of that, and that runs up the south coast, west coast of South America going into Central America. Very big prominent feature. So we've got that compression element full of sedimentary rock, and you'll see, like, it won't be just a simple fold. You'll see like this like crinkling effect where you've got lots of waves of sedimentary rock bending. And you'll see that a little bit more in the subsequent slides. So therefore, we got those two big features. Now, if we go into an event, as this plate slides past this plate, that creates tremendous friction. That causes the causes the plate to lock, and that then builds tension, and that could be hundreds, thousands, tens of thousands, going into millions of years where that force builds. And eventually, like a lot of things, when you have that force, it snaps or jolts or suddenly slips, releasing huge amounts of seismic energy. That's the earthquake. That point at which it slipped, we refer to as a foci or focus. That's the trigger point. And it just because there's slippage here or a sudden break in the rock here doesn't mean to say you're getting that all the way along this line. Okay, so you get differential movements taking place and differential tension forces. The point at which these two plates sliding past each other is a friction zone known as the Benioff zone. So that's a point where you get earthquakes. And later on, when we do earthquakes, you'll see that they can be closer to the surface, 5-10 kilometers deep. They're called shallow focus earthquake. They're usually the worst. Intermediate, and then the deep focus earthquakes. At this collision, at this convergent zone, this destructive margin, earthquakes tend to be of a high order magnitude, right? So they tend to be quite strong, whereas at the constructive, we said, although they're present, they generally speaking aren't that strong. The final bit that we want to talk about here is that as this plate goes past this plate here, we get friction again, and that generates lots of heat. That causes partial melting of the plate, and it starts to turn back into magma. But this is not magma from the mantle, which is less viscous, less in silica, higher temperature. This is a combination of that ocean plate melting. That's because of the friction, but also it is getting deeper, so it's getting warmed up. But it's also got things like ocean sediment in it. It's got lots of gases in it. It's got ocean water, and that creates magma that is much more volatile, stickier, and that then has plays a role in the landforms that are formed as a result. Now, this newly formed magma, let's say around about 700 degrees, rises, breaks through weaknesses in the continental crust. Where there are gaps, they fill, i.e. magma chambers. And when they're full, the pressure buildup can cause a break through the above rock, causing an eruption. And that creates sometimes what we call pyroclastic flows, ash, lava, of a different nature to the ones that are formed on the divergent boundaries. These tend to be much more explosive, rarer or less frequent, and they tend to form volcanoes that are steeper, much more hazardous in the general, and a word that we use, composite volcanoes. And here, as I said, because it's 700 degrees is really hot, but compared to the 1300 degrees you get at the divergent boundary, that means that when it erupts, it solidifies closer to the crater, and therefore you get a steeper profile, and the crater will solidify over quicker as well. So that then aids the pressure buildup for yet another eruption at some point in the future. Okay. So there's a little bit more on volcanoes later on. So they're the fundamental things. So just to repeat, so I've talked about fold mountains, I've talked about ocean trenches, talked about the causation of earthquakes, and we talked about the formation of composite volcanoes. So on this slide, this would be an opportunity for you just to pause and just on a piece of paper, write down what you can remember, alert it, right? I think massively important to do those retrieval activities. So pause. Welcome back. This is just simply a series of slides just to elaborate, just to sort of visualize this a little bit more. So we've got a little bit of an animation here, and you can see the volcano erupting, you can see the plate moving and things like that. But it's quite basic, this one here. But again, just to bring a little bit of animation to it. This slide just gives you some specifics, and you can see, it looks a little bit more real. I'm not sure that's the correct word for this one, but certainly more detailed. You don't need to learn it to this depth, but again, it just brings into a bit more context. And this is the specific one that we were looking at, Nazca Plate, South American Plate, Peru-Chile Trench, and you've got some details there, and you've got the Andes Mountains. A little bit of sequence coming in here. And just to reiterate that, And you can see some details there. Now, the next plate boundaries, which you probably won't have done lower down the years, unless your teacher's like heavily into plate tectonics, which there are many of them. We're looking at where ocean goes under ocean, and it must be because the ocean plate is denser than the other plate. The key area that we're going to focus on is this area here, known as the Pacific Ring of Fire. That's one chunk of it, and you'll see the countries that I'm mentioning soon. Again, just let your eyes adjust. That's the bit that I'm talking about there. You can see those two arrows there and there, the convergence, and you can see oceanic in nature. Okay, the three countries are Japan, Philippines, Indonesia. There are obviously others, but those three countries have a significant number of the active volcanoes. And again, this is where ocean goes under ocean. Very similar to the previous convergent boundary. The one thing we don't get here are fold mountains. We get volcanic mountains, we don't get fold mountains, and we get the addition of island arcs. So again, that's important to remember. So I'm not going to go into the same level of depth that make it clear where the difference is. So there's our ocean plate. There's another ocean plate. You see the arrows moving together, showing the extent of the whole lithosphere. This plate, again, remember the convection currents, moves, collides with this. That subducts because it's heavier, slab pull kicking in. We get the warping. That's the ocean trench. But what we don't get is the fold of this ocean plate. We get the Benioff zones, we get that friction, that stick-slip properties, tension build-up. We've got the Benioff zone. We can have like shallow, intermediate, deep foci earthquakes. And you can see the melting here, again, very similar to before. We get this upwelling of magma. Now here what we got is it breaks through on the ocean floor, creates volcanoes. Those volcanoes continue to erupt. They then surface get to the surface of the ocean, they continue to erupt, and they form islands. They continue to erupt to form volcanic islands or volcanic island arcs with mountains. If you go to the Philippines or Indonesia, Japan, you'll see they are mountainous, very tall mountains, and they have lots of active volcanoes, and particularly dangerous ones, and all the associated hazards that come with that. Fundamentally the same, except we don't have that fold mountain. But again, nevertheless, you do need to know it. So on this slide, that's just a reiteration of the Philippines, so you can see a little bit more specifically. And then finally, there are two of these. These will be in the booklet. Ocean to continental. Second one, ocean, ocean. Key labels, terms, annotated diagram, and put in your paragraph explaining them, and then fill in the booklet. On the subsequent slides after this, there are a couple of more detailed notes and things like that that reiterate and go into a bit more depth what I've said. Thank you very much for listening. Next lesson, lesson 4, will be looking at collision zones. Okay, thank you very much for listening. Bye.